Welcome back to ReddyControls. For the last 1 week, I've been uploading one short video per day, and in those videos, we covered a lot about logic functions. Now I'll try to show those logic functions in the Studio 5000 application. Before we go into the logic gates, I wanted to share a couple of things. The green lines you are seeing on the ladder, these are called as the power rails, and these will be active or green when the controller is in remote run. If the controller is in program mode, you can see the power rails are off, but once the controller is in run mode, the power rails are green, and once the controller is in test mode, the power rails are in remote test. Okay, so we'll put back into the run mode, and those are about power rails. And every routine has a end line, and if we want to insert a new line, we'll go ahead and insert a new line. Some rules about any rung is a rung at minimum should have one output coil or one output energized. So it can be, output A and create, and the rung is good, right? And I can assemble it and it's okay. But what the rung cannot have, so if we insert a new rung and if we just have input, digital input only, and we create a new tag, we cannot assemble that rung. We'll get an error saying like it cannot be installed. So if we go ahead and check, try to assemble that rung, it will say missing output instruction. So those are a couple of rules. At minimum, each rung should have an output. It cannot just have a input, right? Now you might see situations where you would add a output on the left side, and we just call it output B. Even this is also not possible because the rightmost instruction should always be an output. So this does not, it's not a valid combination, right? So always inputs on the left side, outputs on the right side. So if I do that, then the rung is good. So inputs always on the left side, outputs on the right side. Okay. And say for example, if we want to add a branch to this one, right here, if we want to add a branch, we can add a branch, and in this branch I could add, I could add a output C, and the same rule applies, right? Since the rightmost in this branch is a output, if I try to add an input on the rightmost, and we just call it BG input, again, naming convention dash is not allowed, that's why it changed it to, so we'll just call it digital input 1, right? Even this one is not correct because it's missing output instruction on the right side of the branch, so we had to move this back to here. Oh, sorry, it is just to show you. So this is okay, but if I put the right side as input 1, it does not like it. So always remember, any rung should have must have an output, and that output should be on the rightmost element. Okay, and sometimes you would see rungs where this output, Control C, I can just put it there, and we call it output D, create new, create. This is also okay because now it's treating, and this kind of logic is called as a interlaced inputs and outputs, right? So that's all about inputs and outputs and instruction placement. As we talked about, the rung does not need to have an input. All it needs is an output, and that should be the rightmost instruction. Okay. The next we're going to talk about is about how the PLC scans the rung, right? When placing the rungs, the PLC always goes from empty rung is not allowed. Empty rung is not allowed, but the way how the PLC scans them is top to bottom and left to right. So rungs are scanned from top to bottom, and each rung is read from left to right. Okay. And then we talk about logical continuity. So we have any example here. If you have both of these should be true in order for it to do a move statement. That's called a logical continuity. Next, we talk about branches and OR gates, right? So say we talked about AND gates. Say we have in A, in B, new. So and then we have a AND out. So this is a simple AND gate where both the inputs needs to be true for the output to be on. So this is, if I toggle this one and toggle this one, that's when we have an AND out. So this is a simple out instruction, a simple AND instruction, right? And if we want to do the same thing for OR instruction, Control C, Control V there, we put a branch around A and Control X, Control V, and now this would be a OR gate or OR function. Right. So if I toggle that one of the input out, the AND gate, both inputs should be true for the output to be true, but for OR gate, any one of them true makes the OR gate high. Okay. And you could have multiple branches, and even in this branch we could make a AND. So let's new. So what this does is it's an OR and an AND mixed. So it's a either, so logic will go through and it sees a path going this direction or going this direction and come back up and go there, right? So right now, since input A is true, it's going through this direction and getting the OR out. Once I untoggle it, in order to go to the bottom branch, it needs to have both of them true. Okay, that's a AND and OR combination. Now what will happen if I want to bypass this instruction? It's an AND gate, but I want to bypass that instruction. You could put a branch around it. And now what will happen is we bypassed this instruction. So even though this is off and just input A is on, the output of that gate is high. Yeah, I think we covered, and the NOT gate in our example, a NOT would be just take that one, and it's a NOT of A is not A, new, create, and we can assemble that. So as you can see, since input A is true, NOT of A is false, and input A is, once I make input A false, NOT of A will be true. So that's about AND and OR and NOT gates, and some basic rules about rungs and series and parallel branches. That's all for this video. If you like this video, please do like, share, and subscribe. And I will see you in the next video about scaling instruction and how to handle analog inputs in the PLC. Bye.